Hi, welcome to the next track for the OCP Tech Week. I am Damien. I'm the OCP next chair, and then today I will be sharing this track with April and Thomas. Today we line up 8 topics, and we are starting with David talking about OCP NIC 2.0, 400G application and implementation consideration. David, take it on.
Okay, thank you, Damien. Hey, good morning, good evening, good afternoon. Thanks for joining today. Quick introduction, my name is David Herring, and I'm a technologist on the system architecture team at TE Connectivity, and would like to speak with you guys today about 400 gig applications and the implementation considerations. There are several potential applications for 400 gig NICs. And an OCP NIC form factor is a potential applicant for that. And these could include high performance computing applications, acceleration, potentially at the edge or in the telco edge, and server and storage. So as these technologies come running out, we thought we'd take a look at how that could apply to the OCP NIC. Before we jump in, just as a quick refresh, there's 2 form factor definitions. There's the small form factor, or the SFF, which supports up to by 16 PCIe lanes for input. And then you have the large form factor, which can scale up to by 32 PCIe lanes. As we now consider what generation of PCIe might enable a 400 gig NIC slot, as we look at what might be feasible and looking at the bandwidth possibilities, PCIe Gen 4 looks feasible. It does require a high lane count. We can see that it could be up to a by 32 requirement for that connection. So that might be feasible at Gen 4, but Gen 5 seems to really intercept things that's ideal for that small form factor. And you could do it with by 16. And then we can see as generations go, we can get even more narrow link widths. So now that we kind of see what the PCIe generations could do to get the bandwidth to the NIC, let's take a look at what the external I/O pluggable form factors might be to enable this. So if we look here on this table and we try to estimate the number of lanes it would take to achieve 400 gig, we can see that at a by 4, we could do it with 100 gig lanes. For a by 8, we could do that with 50 gig SerDes lanes. And for by 16, we could do it with 25 gig lanes. So this starts to tell the story of the form factors that might have this potential. And this could be a QSFP, a QSFP double density, or OSFP for the by 8 link widths, or potentially even CDFP, which is an existing form factor for by 16. Now that we've introduced what these potential external pluggable form factors might be, let's get a visual of what they look like. So going from left to right, we can see the QSFP form factor, which is by 4, so it would take 2 of these. The next 3, we have QSFP double density, which is a by 8, and could support this at 50 gig length SerDes. With OSFP, there are 2 versions. We have the OSFP RHS, or writing heatsink, and then we have the OSFP typical, which has the thermal solution integrated in the pluggable module itself. And then finally, we have CDFP. There are actually 2 styles. There's a style 1 and style 2. Style 1 is a more shallow plug form factor, so that's what we'll use for today's illustration purposes. Now that we have what those form factors look like, we wanted to lay them out on the OCP NIC form factors themselves, just to get a sense for what type of potential changes might be needed in order to enable these types of form factors. From the left, the QSFP form factor and the QSFP double density form factors, they lay out nicely on the OCP NIC cards. There's no change in height that's required for the form factors themselves. But as we start to consider the OSFP writing heatsink, the typical OSFP, and the CDFP, we can see that these external I/O interfaces themselves start to exceed the envelope of the faceplate, and so it may require a taller faceplate to accommodate it. Now, trying to address what that taller height might be, this is, just for illustration purposes, an example of 4.4 millimeters. And this is really driven looking at a minimalistic impact of just the form factor, not necessarily accounting for some of the tolerances that might come up in the manufacturing of the faceplate itself, and then how the system might be yet. But just to say, hey, as aggressive as we could go on the height, what might this minimum increase be? And so this is an illustration of what a 4.4 millimeter height increase might be. That would increase the total height to 19.5 millimeters in this example. Now that we've gone through that exercise on the large form factor, the same height constraints and the side profiles apply to the small form factor. And so looking at that, hey, let's take a look at the small form factor, because this really seems like a more comfortable fit as we're looking at PCIe Gen 5 that's coming down in the future. One of the next questions that the work group has been discussing is, how do we do the stacking of these? You know, will these be OCP NICs stacked on top of each other as we constrain ourselves to a 1RU faceplate? Here is a side profile view of the potential options. This slide is going to focus on the large form factor and small form factor stacked on top of each other. And just, you know, arbitrarily, just trying to set for some comfortable spacing. Here, you know, looking at that 19.5 millimeter, all dimensions nominal, there's, if we space 0.5 millimeter on top and bottom, and maybe a little over a millimeter in between, some of these look pretty tight for some of the tolerancing, but maybe is it reasonable? So this is a question that we would need to ask ourselves, should we need to go this route? And is it reasonable? This is some feedback that from a system manufacturing and the NIC manufacturing, these are some feedbacks to go in, and maybe these start to warrant some dimension adjustments. The next question would be, hey, what if we want to continue to nest our OCP NIC underneath the PCIe adding card form factor? This was one of the major drivers initially that helped define and set the current height. And it would still be an application of interest. We can see that based on the two form factors, whether it's a low profile or a full height adding card form factor, some of the spacing guidance starts to get tight. And it's also a slightly different use case. With the NIC form factors over and under, they're both front faceplate pluggable potentially, where with a PCIe adding card form factor, the PCIe adding card is already set in reserving real estate within the system itself, while the OCP NIC form factor is still serviceable and hot swappable from the faceplate.
David, I want to check, is your audio drop?
Okay, sorry about that. Is my audio back?
Yep, you are.
Okay. So feedback on these types of manufacturing tolerances would need to be considered as well. next question would be, what about the ASIC placement? As we look at the NIC placement itself, we need to look and consider the PCIe lanes that are coming in, what the routing potential would be from the ASIC to the IO form factor itself, and are there any concerns with the routing? Here are two layout examples of varying ASIC sizes, and in both of these cases, they do look feasible. And as we look at the form factors themselves, we have to ask ourselves about the power considerations. The small form factor NIC, today can go up to 80 watts of power, and the large form factor is scalable up to 150 watts of power. When we look at the pluggable module form factors, QSFP power levels roughly up to 3.5 watts. And if we're requiring 2 of those, that could potentially be 7 watts inside of the module. The QSFP double density, we could be looking at above 14 watts as well for OSFP. And then CDFP having a power envelope ceiling of about 12 watts. And then we also need to consider the ASIC path. What is that going to be? As we look at the larger lane counts and we start to go down, over time, we could see a slightly reduced power required, since with a fewer number of lanes to get this. So that's could play in our benefit, but we want to make sure that whatever the ASIC power requirements are and whatever the pluggable medium requirements are, that both the IO form factor and the ASIC itself can be supported within the envelopes of OCP NIC. Now that we package all of that into the NIC form factor, there's also the system performance level considerations. Whether this NIC is going to be applied in the cold aisle, which would be front access, or if it's going to be in hot aisle, which would be rear access. These have slightly different thermal considerations, both from an airflow perspective and the localized ambient temperatures that's going to be used. And so this can limit what the power might be for an ASIC. And so the relationship between the NIC cooling itself and how we're going to actually handle this in the system would also need to be considered. What type of height increase might be needed to achieve the amount of airflow for the desired outcome and cooling capability. Another question might be, when we look at these external form factors, how do these compare with some existing form factors out there? So this is a good data illustration to help show how some of these form factors might fit in something that everyone may have been used to seeing today and in the past. Whether it's an external mini SAS HD or CDFP, this is how they fit on PCIe adding card form factors or PEC-FF. And QSFP double density and the OSFP writing heatsink also fit on these form factors, where an OSFP typical is still a little too tall to fit within the faceplate constraints of that form factor as it's defined today. So to bring it together, one of the things, call to action, we have a session following this one that's going to go into a little more detail and dive into what a taller OCP NIC might be, what some of the background, the progress, potential. And this will include some system level constraints that have been considered and also use different analyses. Self-reflection, ask ourselves, are the influencing constraints that we're considering for this 400 gig NIC, are they applying to all the applications that we see within the industry? And if you haven't joined the OCP NIC-MES work group in meetings before, we encourage you to join our community and get involved so you have a voice in influencing what this taller form factor might be, applications, et cetera. So with that, do a time check and see if there's any questions.
We have a couple of people on the line who would like to ask some questions. So I'm going to go ahead and add them in here.
Yeah, and apologies for the technical issue earlier. Hopefully my audio is still coming in clear.
Hi, Bernadette. I saw that you joined. Do you have a question? You are on mute if you are talking.
Yeah, I apologize. I joined late, so question on me. No, I don't. You hear me?
Hey, yes, we can hear you.
Oh, good. Yeah. Like, so sorry, no.
And Scott Summers, I see that you joined the line. Do you have a question for the group?
I don't have a question, but I just wanted to thank David. I thought it was an excellent presentation.
No, I
So
don't. You hear me?
Oh, thank you, Scott. Hey, yes, we can hear you.
Oh, good. Yeah. Like, so sorry, no.
You have a question for the group?
no, I just will repeat
I
it.
don't have a question, but I just wanted to thank David. I thought it was an excellent presentation.
No,
So
I don't. You hear me?
Oh. The electronic hallway echo.
Hi, David. I have a question.
Yes,
So,
thank you, Dave.
yeah, do we have to move to a extension of the new of this form factor if you want to go with 400G? Is there any other options available?
So with the 400 gig, as far as the external pluggable form factor, the existing pluggable form factors that do fit it do reside with the QSFP and the QSFP double density. Just within the faceplate height constraints and the maximum component height constraints that are a part of the PCBA definition. And those would be the available existing options. I would say one potential out-of-the-box option could be a passive optical interconnect. There are some of those that could be fit into the faceplate, but as far as an electrical interface, those seem to be what's available and fit the bill today.
I see. How about 100G SerDes?
100 gig serviceability.
Yeah.
So that could be opened up to a couple of other additional form factors, especially as we're looking at different SerDes speeds. So if we're considering a 50 gig SerDes, SFP double density or dual SFPs may be an option, or reduced lane usage of a QSFP. could be of consideration. If it was 100 gig SerDes, then we just use a couple SFPs. But that seems to be a little bit further out. But those would be some options.
Cool. Thank you.
All right. Thanks so much, David.